Hello, everybody. Welcome back to a new episode for the midnight session. We're going to follow the same procedure for those that are new. I'm going to be talking about the ecosystem updates, technical stuff, and at the end, I'm going to open the mics. People can write their questions on the chat. And if you want to speak up, you can raise your hand and I will invite you guys to the stage. Okay, so let's start talking about the hackathon. For those that don't know, today at in 1 hour and a half, we're going to be holding the midnight presentations of the tooling hackathon. That's why I have this in my background. I'm going to be one of the juries, so I'm really happy about that. We're going to be looking at all the presentation projects that people were building. I cannot say much yet, but I can guarantee that people are going to be really happy, and all these projects are going to help the ecosystem grow because it's going to give a lot of context on how to build different kind of toolings, templates. So just I gave a summary here on Twitter. You can see that we're going to have all these topics, projects we're building, taking consideration templates, scripts, indexers, scaffolds, and formal verification. So really interesting projects. You cannot miss the hackathon presentation that's going to happen in 1 hour and a half. It's going to be on YouTube. I share on my Twitter the link. Okay. So regarding the education, we have 3 topics on education. We have the academy, we have diaries, and we have blogs. As we go through the sessions, we're going to be touching on each specific topic. But this session, we're going to talk something related to the diaries, which is that topic related to hex, batch 32 to hex, and hex to batch 32. So let's open that diary and let's discuss it. So it's kind of technical, so we're going to go through this material. I mean, it's really short, so it's okay to read it, and I will explain it as we go through. If you have any questions, you can just write it on the chat, and then so you remember it, or you just keep it by yourself, and then you can join the stage. Perfect. So let's see what we have here. From hex to batch 32M. Midnight's new standard for safer, smarter addresses. The Midnight ecosystem is evolving. One important change is the new default address format, batch 32M, which is a human-readable address format with error detection. So these 2 things, it's really important to remember why they shift from hex to batch 32. Human-readable addresses and error detection. I'm just going to give a context here that I've seen on YouTube one time. This guy typing his Bitcoin address and he misspelled something, just 1 letter. And he actually sent those funds to a completely different address. So pretty much this batch 32M protects the user from doing those kind of actions. Midnight now uses batch 32M as a default format for wallet addresses and public keys. So it's just not addresses, it's also public keys. This change improves readability, safety, and metadata clarity. Hex, it's deprecated, but is still temporarily supported for backward compatibility. So there is other developers that have already been doing applications. They are using these old kind of addresses, but they don't need to change right away. I mean, their code, it's still going to work. So this is something nice when people are writing libraries to make it backward compatibility. So you don't need to change it right away, but it's recommended for safety for your users. So this post explores what that means, why it matters, and how to adapt your applications accordingly. So let's take a look. Why move away from hex? Hexadecimal base 16 encoding has been the long-standing default for representing blockchain addresses due to its simplicity, broad tooling support, and compact format. It provides a direct, low-level view of binary data. So it boils down to compatibility when it comes to libraries. I mean, hexadecimal, it's supported by a lot of libraries. Base32M now is going to shift and try to accommodate into different libraries, but it's still the safety, it's a bigger trade-off for not to shift, right? So that's why they are using now Base32, but before they decided to start with hex encoding. So now introducing Base32. So they mention here really important topics. To address the limitations of hex encoding, the blockchain ecosystem introduced Base32. So there's two important things here, Base32M and Base32. So Base32M, it's an upgrade from Base32. So Base32, a human readable address format originally developed by Bitcoin Segwit. Base32M, it's a refined version of this format, designed specifically to support new cryptographic construction such as Taproot, and is now used in the Midnight ecosystem. Unlike hex, Base32M encodes data using base32 character to avoid visually ambiguous characters like 0 or O, right? And includes a strong checksum for detecting errors caused by typos or miscopies. So remember that that story that I just told you guys at the beginning, that guy mistyping the Bitcoin address. So this checksum doesn't allow the user to do that anymore. At Base32M, the string consists of 3 parts: a human readable prefix that identifies the network and address type. So this is a prefix, for example. We have this. This actually tells us a lot about the address. It's coming from the Midnight network, MN. It's a shielded address. We're gonna have a shielded address as well in the future in Midnight. And it's on the network test. So pretty much we have a lot of metadata from that, a lot of context. A separator, and then the encoded payload, which contains the actual data. So we know the address is composed by a coin public key and encryption public key. The result is a format that is not only safer and easier for users to handle, but also rich in metadata, making it far more suitable for decentralized applications where clarity and security are critical, where Base32 is used in Midnight. The adoption of Base32 isn't limited to a single library. It's coordinated shift across the entire Midnight ecosystem. So Midnight ecosystem, we have providers, we have different libraries, SDKs. So all these instances and SDKs, they have shifted to this new architecture, this new Base32M architecture. So they name here Wallet SDK, the Wallet API, the dApp connector, the Lace Wallet. So all these new instances and libraries are using this framework. So for those that are planning to shift, since it offers backward compatibility, if you want to declare an address, you use it like this with the new Base32M. Address is of type string. If you want to declare the old type using hex encoding, you declare your address like this, address legacy string. You can use both right now, right? The same thing for coin public key. Coin public key is a string. This is the new format, Base32M. And if you want to declare it in the old way, you use coin public key legacy. So at the end, you just have to write legacy at the end if you want to use the old version. And the same thing for encryption public key. If you want to use the new version, Base32M, you just type this one. And if you want to use the old version, you just put a legacy at the end. So we have encryption public key legacy. As I mentioned, we have backward compatibility and migration, and the Midnight team is providing this library called Wallet SDK address format, where they provide this function. And this function allows us to decode an address that it's in base 32 and have it on hexadecimal address. So there are some libraries that they expect hexadecimal addresses. But for the user interface, they use this base 32. So what happens when you have this base 32 address provided by the wallet and you want to use it on a library that wants an hexadecimal format? You use this function to decode. Okay, so at the end, the summary, it's base 32 is the default address now. The hex format fields, it's deprecated. Nevertheless, backwards compatibility, they took that in place. The migration is simple, as we showed here. You just have to remove this legacy stuff. And if you're building an app, make sure you're using the midnight.js 1.0. Perfect. So this is page 32. And you're going to start seeing that a lot when writing code. Perfect. Now let's go to the technical part. So let's open our favorite IDE. In my case, I'm using Windsurf. So in the last session, we talked about these two functions: display counter value and create wallet and midnight provider. And we introduced this new argument of type wallet. And we saw that wallet, once we initialize it and we get the first value from the wallet, we can grab a lot of information from the wallet, like sync progress, encryption, and all these new variables. So in this session, we are going to study the meaning of these variables. So for that, we have to understand what is a wallet in Midnight, what we actually hold within our wallet. Perfect. So first, let's understand the architecture. For this, let's go to this graph that we studied the last time, right? And we explained that we have this private information, we have this public information, and we have this Merkle tree of commitments and notifiers living on the CSwap protocol, right? So the CSwap protocol, it's where we actually have in our wallets. So just let's represent here a person, right? Let's call it that a person that they have a wallet, right? We have a wallet. So what's in that wallet? Actually, what we have there, it's just a representation of this Merkle tree in here, but not the whole Merkle tree, just the tokens that we own, right? So, as I mentioned, we have an address, right? And that address is divided by a coin public key and encryption public key. This coin public key, it lets us, it gives us the means to actually spend the coins, and the encryption, it gives us the way to actually see the coins. And when I say see the coins, what happened? This is a Merkle tree, and these are commitments, which are pretty much hashes. So a hash, we don't get to see anything. We just see a hash. With this encryption key, we can actually see what's inside this commitment and actually see our coins. So let's say that from this Merkle tree, this commitment, from this Merkle tree, this commitment and this commitment, it's yours, right? So this commitment is going to live here. You're going to have one commitment and another commitment. With this encryption key, you're going to be able to see these hashes. And with this coin public key, you're going to be able to spend these hashes. So you can see, you can relate, for those that are familiar with Cardano, that this works as a UTXO. These are inputs and outputs. Okay, perfect. So we now know what's inside our wallets. It's just commitments that we can actually see or we can expand. So now let's correlate to the meanings from the code to actually this graph, right? How they correlate. Let's start with the address. So we have a state address. What is this address? We mentioned the address. It's the concatenation of the coin and the encryption public key plus some context. What is this context? I just show you on the diary that we have now. Let's see if I can find it. See here. Now an address it's in 3 parts. One, it's the midnight shielded address test. This is kind of the metadata. Then we have a separator plus the encoded payload, which consists of the coin public key and encryption public key. So we can see that we have a coin public key and encryption public key. This is our payload plus this metadata. Excellent. So we now know what is an address. Now let's understand what it's available coins. Before understanding available coins, let's understand what it's a coin, right? So coins, it's what I mentioned here, that we have these commitments. Within these commitments, it's actually where our coins lived, right? But this is a hash. With this encryption key, we can actually see the coins. So coins, it's just what's inside these commitments. This is coins. Now, let's understand what is available coins and the difference with pending coins, right? So, later in this session, we're going to see that for creating a provider for balancing our transaction and submitting our transactions, we can actually include in the balance transaction coins. So this is our intention to send coins, but they haven't been processed yet by the blockchain. So pending coins are transactions that have been submitted, but is still not processed. And available coins are coins that have already been processed by the blockchain. So that's the difference between available coins and pending coins. Balances. Okay. For balances, let's take a look at the log to understand what's inside these balances. So I have already created a transaction using this circuit to actually see what we get from our wallet using these balances. So let's open the log, and we can find here the specification of our wallet. We can see here that the address, it's this type. See, you can see we have a midnight shield address and deployed, and then we have our payload. This is the payload, the conjunction of our coin public key and the encryption public key. Then we have our balance, and our balance is 0. So we don't have any coins. It's just a number. Now, let's see, we have already know what it's coin public key, and we know what it's encryption public key, and then we have nullifiers. So in a previous session, I explained what is a nullifier, and for our wallets, we have it as well. Because since, let's open here the graph, since we have some commitments, each of these commitments or hashes, it's associated with a nullifier. So this architecture of commitments and nullifiers, it's a way to actually spend coins without disclosing the commitment. So since everything is private, how the other person know that that coin hasn't been spent? So we use nullifiers for that. Excellent. And then we have the sync progress. So the sync progress, it's just when we are actually syncing our wallet, we can get to know at what state our wallet is based on the syncing process. Excellent. So now we are gonna actually declare the providers. So how do we declare the providers? Since the function that we are looking at right now, it's create the wallet and the midnight provider. We started what we get from the state, but once we get the state, we're actually gonna build those providers. How do we build them? Okay, let's see. First, we declare the coin public key. Okay, we know that. How we do that? We use the state object and we get the coin public key. For the encryption public key, easy. We get the state and we have the encryption public key. Now let's define two functions: the balance transaction and the submit transaction. So the balance transaction, it's a function that we're gonna pass two arguments. One, it's a transaction that it's unbalanced, and we're gonna pass the new coins. These new coins, it's our intentions for that coins that we want to actually include in our transaction, that our wallet is gonna see it, and we're gonna be able to see it beforehand by looking at the pending coins. We learned about these pending coins. So now let's build that provider, which is the balance transaction. For that, this is pretty much boilerplate. Okay, you don't need to actually, it's okay to understand it, but you don't have to memorize it. So let's see what we have here. We are passing the transaction. This transaction is coming from midnight.js, right? When we write our contract using Compact, then using midnight.js, we actually get this transaction. So midnight.js builds the transaction for us. What we are doing here is balancing our transaction and submitting our transaction. What is this balancing transaction mean? What do you mean when I'm saying balancing a transaction? So let's see here. First, we have to add these new coins that I mentioned using this format. So we are using serializing and deserializing to pass from the syswap world to the ledger world. So this is just the way the serialization works. You don't need to understand how these libraries are working between each other, but what we are doing here is just balancing the transaction. So when you balance a transaction, you create the transaction with your intentions, and then you have to grab some resources from your wallet and actually attach it to your transaction. For example, who's gonna pay the transaction fees? It's the user. So this balancing of the transaction, it's actually adding coins or transaction fees into this unbalanced transaction. Then we have to prove the transaction. We use the proof server for that. And after proving the transaction, we just decode it, right? We first encode it to actually balance it, to prove it, and then we have to transform that transaction back to syswap. So we use that this deserialize method, and then we use this function of create balance transaction. So you don't need to understand what these libraries are actually doing. This is just boilerplate. What you need to understand here is that we are actually balancing, we are proving, and then we are transforming the transaction so we can actually submit it to the network. So this new function, we are actually passing a transaction that it's the output of this balance transaction, and then we are submitting that transaction using our wallet. So you can see here with the midnight.js and the Compact, we create the unbalanced transaction, and then we can balance the transaction that includes proving, and then we submit it. So we already have our providers. It's just that easy, right? Once you just declare this provider, then when you're writing your code, you don't need to remember all this stuff. You just call balance transaction and you just call submit transaction. Excellent. So with this session, that's it. I mean, it was a lot of information, so you can go through this topic again. And for next session, we're gonna talk about syncing, right? We mentioned here that we have the sync progress. So when you actually want to sync a wallet, we want to declare some functions as wait for sync, wait for sync progress, and wait for facts. So we're gonna see that in our next session. Okay, so now I'm gonna open the mics. I'm gonna see if somebody has put any questions in here. And if you want to speak up, you can raise your hands and I can, let's see first the questions here. Honorrat is asking, nice background, Eric. Thank you, Honorrat. Is today's midnight session going to be the last? No, Honorrat. I mean, the midnight sessions are gonna go through the whole year. I mean, we are doing these sessions to give awareness to people how to build on midnight, how to create applications. So the objective at the end is giving awareness regarding ecosystem. And for building, we actually want to train people to build end-to-end apps. Okay, Aylan have a question here. No questions. Thanks for this. I learned a lot. Thank you, Aylan. Well, yeah, mission accomplished. This is the objective of these sessions. Okay, let's see. Thanks for the work you're doing. Thank you, Honorrat. And something that I always ask, it's any feedback. Island, Honorrat, if you want to see something, I mean, the idea here is to, I mean, this is the 7th session so far. And we are starting from 0, right? So new people that join, they can go through session 1, 2, 3, 4, 5, 6, 7. As we go by, I mean, things are going to be more complicated, but people can go back and see the older sessions. And so since everything is changing way too fast, sometimes our topics that are more important to some people, other topics that people want. So all the time I'm giving feedbacks. Eric, can you talk about this the next session? So if you want something that I go through in one session, you can write me and see how I can fit it into the next session. But the main idea is that we are starting like at the beginning, and then we're gonna go through really more complex contracts and stuff. Yeah, Island's mentioning maybe next time you can drop the link of the screen you're sharing so I can follow along while you go over it. Maybe the next time you can drop the link of the screen. The website has changed a lot. Learning the website, it's much easier now with the AI tool. Yeah, for sure, Island. Now the website, that the docs, they have integrated this Kappa AI. And it's trained using this RAG algorithm. It's really nice. So the AI doesn't hallucinate, right? They actually answer you back based on what's available within the documentations and actually provides the links. So you can reference those information back. And Island, I didn't understand the first feedback regarding the link of the screen. What do you mean? Thanks for the forward doing. Yeah, thank you, Honorat. Yeah, it's a link of the page you're going over during the sessions. Okay. No, thanks for the feedback, Island. You mean like kind of these links here, right? Yeah. Okay, Island, thank you for the feedback. Okay, perfect. So so this is all for this session, and next session is gonna be on Tuesday, and we're gonna keep going through the we have this structure, right? We are looking at the counter example right now, and we are finishing the API folder, all the functions that are within, and then we're gonna go through the CLI process, how to test it using a TUI, and then we're gonna go through some test frameworks. We have tests here in the CLI, and also on the contract we have this test. And after that, we're gonna go through the front end, how to integrate it using a front end. And after that, we kind of learn how to integrate all the instances and features using a really simple contract, but still we've learned like a lot. And then we just, in the next examples, we start adding more complex contracts and going through the same process, right? Learning how to write a contract, the CLI, and then the UI. Well, guys, thank you very much and see you next session. Bye bye.